Good evening, folks, and welcome to our virtual Skill Futures Workshop, Python Basics and Robotics, hosted by Skills Canada, Newfoundland and Labrador, and facilitated by the Canadian Robotics League. Thank you all so much for registering and attending today's event. We hope that by the end, you feel like you have a better understanding of the fundamentals in Python programming language and how it connects to the robotics industry. Before I pass the screen over to our wonderful facilitators of today's event, I'd like to briefly introduce SCNL to those of you that have never heard of us before. Skills Canada, Newfoundland and Labrador is a nonprofit organization that encourages and promotes skilled trades and technology careers as viable career options to youth in our province through experiential learning opportunities like this Skilled Futures Workshop. Along with our programming, Skills Canada offers a wide range of competition areas for youth in our province to compete in and showcase their skill sets and pursue their career passions. At our intermediate level, we offer a competition area called First Lego League Robotics. And at the provincial level, we offer a competition area called Mobile Robotics. So we're really happy to be hosting an event today revolving around this career field. My name is Jess, and I'm the Diversity Project Coordinator with SCNL. I work within the organization to help expand its existing programming to be more inclusive for diverse communities, as well as create and deliver new content for these communities that are directly related to their career passions, while helping eliminate barriers they face when accessing career exploration opportunities. Before we begin, I'd like to kindly ask the audience to please keep yourselves muted while the workshop is occurring, and you are more than welcome to put questions that you have in the chat box throughout the workshop. Our facilitator has noted that she is welcoming your questions at any time and will be happy to answer them when you ask. Also, a gentle reminder that this event is being recorded for anyone who may wish to have their cameras on. I will now pass the screen over to the president and founder of the Canadian Robotics League, who is going to introduce their new organization. Colby, the floor is yours.
Thank you, Jess, and welcome to everybody to this workshop. I'm Colby Pryor, founder and president of the Canadian Robotics League, and our mission at the Canadian Robotics League is to provide universal access to STEAM education through robotics competition, workshops, and STEAM initiatives. We have a firm belief that everybody should be able to participate in these programs and these opportunities, like Python Basics and Robotics. Divya is a computer science student, a computer engineering student, and she has a strong background in computer programming and computer engineering. And we're really glad to have her to present this presentation to you today. So without further ado, I'll hand it over to Divya and let's get started.
Hey everyone, thank you so much, Colby. Thank you for introducing me. Thank you, Skills Canada, for helping us host this event. I apologize for not having my camera on. I'm having some technical issues, due to which I'm not able to get my camera turned on. Without further ado, I would say let's jump into the presentation. Let me just share my screen. Oh, and before we jump in, like what Jess said, if you have any questions between my presentation, please feel free to put it up in the chat box. I will reply to you as soon as I see it. Great. So for this presentation, what do you need? Just whatever you have right now, a computer and a stable internet connection. You will not need anything else for this. About us. So the Canadian Robotics League is a non-profit organization dedicated to providing universal access to STEM initiatives through education and competition. Our workshops, seminars, and competitions provide everyone, regardless of geographical restrictions or educational background, the opportunity to learn something new. And today, in this opportunity, we are going to learn Python and how we can use Python to program robotics. So why Python? Python is a very easy programming language. It's a high-level language. It's simple to learn, easy to code, and easy to maintain. So as everyone knows, computers work off of electronic signals. So it's just high signals and low signals. We call them zeros and ones or binary codes. Programming in binary is extremely hard, and hence we have languages like Python, Perl, C++, Java, JavaScript that's easier for humans to understand. They make sense to us. And this is then converted into, say, bytecode or machine level languages by the computer itself and then executed. So to code in Python, you will need to know a certain syntax, a certain methodology, a certain procedure, certain rules that you have to follow, so that once you type, your computer understands what you are typing and it can execute the code. So the first aspect of any programming language, and in particular Python, would be variables. So variables are basically reserved memory locations to store values or data. And for example, say you want to allocate a certain amount of space in the memory to store your own name, right? And inside the memory, you can have your name stored. My name is Divya, so say in that memory, I'm going to have Divya stored, but I need to give that block of memory a certain name, and that name of the block of memory itself is called a variable. And there are certain rules as to what a variable can be and cannot be. So it must begin with an underscore or an alphabet. It cannot begin with a number, and it cannot have any spaces. So for example, num, N-U-M, is a valid variable name. Decimal, valid variable name. All of these, if you can see my cursor, all of these are valid variable names. You can make them start with a certain underscore. You can make them, they can have numbers in between, but they cannot have any spaces in between, and they cannot start with a number. Next up is any doubts in this before I move ahead. If you have any doubts, I'm just going to give you a couple of seconds to just, put it up in the chat box. Awesome. I think we're good. Moving on. Next up is keywords. So there are certain words reserved by the language itself for a certain functionality. For example, the word while is reserved by Python because it has a certain definition, a certain meaning that I will explain what it is to you later. So words like, say, while, for, if, else, break, return, int, char, all these are words reserved by the program itself, the compiler, and you cannot use these as variable names. Did everyone understand this? Any questions on this? Awesome. Moving on, next we have operators. So say you have, say you want to write a program that functions as a calculator, right? So the person, or you rather, the user, will input to the computer, say, two numbers, A and B, all right? And depending on what you want it to do, has to say add the two numbers, or subtract them, or multiply them, or divide them. So first up, what you would do is define the variable. You would tell the Python compiler that, hey, I have two variables. One is A, one is B. The user will give you input, and you have to add. So to add two numbers, you would use the addition, the subtraction, multiplication, division. So all these operators can be used in between two numbers for giving you a certain output. And you can assign this output, this calculated value, to another variable, also which you can define as you would any other variable. Here on the right side of the screen, the one that where I'm moving my cursor above, these operators check for whether two values are equal, or they're not equal to, or less than, or equal to. So these operators will return a Boolean value, which is true or false. It will compare, and it will tell you if the entire expression evaluated to either true or false. It might be a little jumbled right now, but when I do show you examples, I feel that you would understand this a little more. So just try to keep up right now. It's okay if you don't understand something completely. When I show you how to use these things, when I show you some examples, this will become easier for you to understand. Next up in the bottom, you have these three operators, and, or, not. Okay. So these also check to see if a statement or if a certain line is true or false. the AND statement basically has a part 1 and a part 2. It returns true only if both part 1 and part 2 are both true. As for OR, either part 1 or part 2 have to be true, and not just negates the one statement you have, reverses the result that is, and returns it to you. So if you say, if you put in false into the NOT operator, it will give you back a true. It just reverses whatever you put in. So far, so good, everyone? Awesome. So using the variables, keywords, and operators, you can make statements, right? For example, the addition statement that I mentioned in the previous slide, I say x is 5, y is 10, and then I assign the sum of these two to z. Instead of having 5 and 10 here, I can also have x and y. I can have x and 10 or 5 and y. This will just take the sum and assign it to z. Statements are not limited to being this way. A statement is basically any instruction written with a combination of, say, keywords and variables and operators that the Python interpreter can execute. So this is what helps you make sense of the first three slides, that whatever we saw in the first three slides. So there are different types of statements. The three you see here under examples, I would say, are the simple, easy statements. Moving on, you have something called a conditional statement. So the block of code is executed if and only a certain condition is satisfied. You have many types of conditional statements. I am going to be exploring a few with you. The first one being an if statement. So before we jump in and I explain what an if statement is, these two lines are not interpreted by the Python interpreter because of the hash sign in the beginning. This hash sign tells the interpreter to ignore whatever is here, simply because it's a comment. These are written for us, the programmers, to understand what the code is about. Moving on to if statements, what this does is if, and then this condition here. If this condition is true, this line is executed. If it is not true, this line is skipped, or rather the block of code is skipped and the next line is executed. Here, going back to our previous slide about operators, this is the operator that we use. It's not equal, right? So going back to our conditional statements, I'm right here, I'm saying if q is not equal to 0, I'm assigning r to p by, I'm assigning p by q to r. And the condition here is that p, q, and r have already been declared and initialized, and p and q have been initialized. So this is a simple if statement. Say you want to do something if a statement is true, else you want to do something else. This is where an if-else statement comes into place. So say you want a program that finds difference of two numbers, the bigger number minus the smaller number. So here you say if a greater than b, then c is a minus b, else c is equal to b minus a. So this is what I mean by a high-level program, where if you read out the code, you understand it. It's pretty easily understandable instead of, say, zeros and ones, which would take a lot of time to understand what the code is doing. The only thing is that you need to keep in mind the syntax. So if space the condition and this colon. This colon is very important, and all the lines underneath particular if statement will be executed. Next, we have if, elif, else. Elif is basically a condensation of else if. So say you want, for example here, if q is equal to 0, equal to is the, you put equal to, but it actually means if q equal to 0, then I'm just going to say r is 0. Basically, I'm finding p by q, right? And then I'm saying if p is greater than q, I want r to be p by q. Else, I want r to be q by p. So here you have three different conditions evaluated and executed depending on what condition is satisfied. So far, everyone following me? Any questions? Perfect. Next up, we have nested, have an if-else statement inside an if, or you want an if statement inside an if-else. All this is possible. You just have to have it within. So here, what I am doing is, if q is not equal to 0, so first I'm checking if the denominator is 0. If the denominator is not equal to 0, I check which is greater. If p is greater than q, then I say r is p by q, else I say r is q by p. Now, if q, so this if else will only be checked for if q is not equal to 0. But if q is equal to 0, I skip this entire block of code and I jump to this else. And this is executed. So one important thing to note, indentation, or rather the space that you leave from the beginning, from the margin mark, is very important in Python. If this R is brought back here, Python will assume that this statement is no longer nested within this if or this if. The only reason this statement gets executed within this is because of the indentation. Same goes for this block of code. It's executed under this if because of the indentation, the space you see from the margin line. So keep in mind, if you forget to indent your code well, you will have issues in execution and your program will not run properly. Any question, guys? Great, I'm happy everyone understands what I'm talking about. Moving on, we have loops. Say you want a program, all right, that adds the numbers from 1 to 10. Instead of saying a is equal to 1 plus 2 plus 3 plus so on till 10, you can just tell the code, you can use a for loop and tell the code to do the same thing with just one line, okay? Or you could also use a while loop. So loops help you in the sense that the block of code is executed repeatedly for as long as the condition is true. So the minute the condition is evaluated to be false, that block of code is exited and the next line of code is executed. The first type of a loop would be a while loop, okay? So here what I am doing is I am multiplying all the numbers from a given number to 1. So say you want to multiply numbers from 10 to 1. So basically a factorial function. So while b is not equal to 0, so this line of code will keep getting executed for as long as b is not equal to 0. It says a, so this is a shorthand operation. What this means is that a is equal to a into b minus 1. So this is a shorthand operation. The equivalent of this would be a is equal to a into b minus 1. And then I say b minus minus. So b minus minus is equal to, basically means b is decreased by 1. Or rather b is equal to b minus 1. This last line you see here, b minus minus, is very important because it makes sure that this loop is not infinite. For example, take for example, b is equal to 5, okay? So right on top here, before it enters the while loop, b is 5. While b is not equal to 0, the condition is evaluated to be true. So this line is executed. Assume that in the beginning, a is 1. So a into equal to b minus, a into equal to b minus 1. Here what I am doing is, I'm saying a is equal to 1 into 4, because minus 1 is 4. And the next line, I am saying, reduce b by 1 more. So now b becomes 3. I go back into the while loop. It checks again. Is my b 0? No, it's not. So again, it executes the next line where now a becomes 4 into 2, and then again decremented. Without these two decrements, my code will forever stay in the while loop because of the value of b, which never gets updated. So always make sure, this is called an infinite loop. So always make sure that in any loop you program, you have your exit condition comes to true. You need to have a point where the exit condition comes to true. The next type of loop is a while else loop. Okay, so here I am just basically in while else loop, it has a while and it has a condition. So for as long as this condition is true, this gets executed over and over and over again. So here I'm initializing my count in state is already declared, and my condition if this count is less than 100. I keep increasing count. So let's say count starts at 0. It keeps increasing until it's 100, and my status is false. When count hits 100, this while loop, it comes out to be false. So these two lines are skipped. It goes to else. It executes just once. So here I'm changing my status to true. So in a while else loop, the while block of code will keep executing for as long as the condition is true. And as soon as the condition becomes false, the block of code under else will be executed just once. So far, so good. Any questions? Awesome. Guys, so I cannot see your face. It would be great if you could send some reactions my way so I know that you can understand what I'm saying and that you're following. Moving on. The next one is a for loop. Oh, my bad. The next one is a for loop. So what a for loop does is for I is equal to 1 to 100. Basically, this loop says I goes from 1 to 100. So the first time this line executes, I is 1. The second time, I is 2, 3, 4, 5, so on till 100. So I keeps incrementing 1 to 100. And each time I is incremented, the block of code under for is executed. So in this case, this is a program that finds a sum of 1 to 100. Any questions, guys? Great. So after loops, we have functions. Okay. So function is basically a block of code that can be used multiple times and is executed when called upon. So the syntax for this would be, you say def, which is once again a keyword. Def is a keyword, you say def, and where you see these braces, you have a function name. So you can call it sum or subtract, any name you choose. This would also be a variable name. So any name you choose, you can put in. And parameters is what you pass on into the function. So I will explain what parameters are and what it is in detail when I show you an example of the code later on. For now, just remember that parameters are any variables that you want your function to have access to. Underneath that first statement, you need to have a colon, by the way, in the end. Please don't forget that. You have the block of code to be executed. This could be 1 line, 10 lines, 100 lines, it doesn't matter. The entire block of code indented well to be executed. And then in the end, you could have a return statement. A return statement is basically a value that is returned from the function. So when you call this function, to execute or do a certain task, it will return a certain value. It could return a certain value, and that is decided by this return statement. So let's see a quick example. Okay, so def, that's my keyword. Check odd is the name of my function, and then here it's num. That's a variable I'm passing in to the function. So basically, how I'm looking at it right now is num is a number that has already been defined earlier on. Its value already been set and it's been passed on inside into this function. Found is a variable I'm defining here. I'm saying if found is true, I'm first initializing found to be true. I'm saying assume that in the beginning I've already found it, and then I say if num mod 2 is not equal to 0. So num mod 2 mod, as you may remember, let's go back to the operators page. Num gives you, it's the modulus function. It gives you the remainder. So when I say num mod 2, I am checking if that number divided by 2 is equal to 0, because only even numbers when divided by 2 give a remainder 0. If the remainder of these of num and 2 are not 0, then I'm saying found is true because I have found my odd number. Else I have not found my odd number, so I'm setting found to be false. Here I say return found, which means every time I call this function. So in the next line you see here, to call the function, this line, I call this function, it will give me a certain value, and that value is found. I can display this value, I can use this value for other operations, but this value is basically returned by the function. So far, so good, everyone? Perfect. Okay. There are some predefined functions already given by Python so that you can use these for certain functionalities. For example, print. If you tell print is once again a reserved word that you cannot use for any variable name. If you say print and put in and open parentheses and put in whatever you want to print here, the program will basically output or display this value to you. Similarly, when you say input and say bracket and you give a variable name here, or you can even leave it blank, it will take in a certain value, and depending on what variable you have here or you assign this input function value to, it will assign it to that variable. Once again, if these things are a little shady right now or a little hazy in your mind, don't worry. When we go ahead and start programming and using all these concepts, you will understand exactly what I am trying to explain here. Another example would be this. POW is the short form for power. So when you say power base exponent, it basically says base to the power exponent, and it returns that calculated computed mathematical number. Does anyone have any questions so far? Awesome. So let's get coding. There are two different parts into coding that we're going to do today. One is just base level Python coding, and the other is we're going to try to use an Arduino board, which is just a circuit board to do some cool things today. I'm going to. So everyone, open your Chrome browser. Let me share my screen with you. Give me a second. Okay. Okay. So open your Chrome browser and type online GDB Python. Your first result here, online Python debugger, online editor, online GDB. Click on that and open it up. This should be the screen you can see. Is everyone there? Awesome. If anyone would like to ask anything, please unmute yourself and go ahead and ask me. Wait, I have. Yeah, perfect. Okay, so I'm not sure if everyone can see this, but I'm going to assume you can. This is a simple program that just says print hello world. So basically, this is where you type your code. This is where the program or the computer interacts with you or displays everything. And when you say run, it will show you what it'll basically interact with you, right? So this is just, comments. You can take it off. It doesn't matter. So print hello world. Let's do a quick exercise. I'm going to delete the entire code. Please make your entire canvas blank so that you can practice typing it from scratch. I'm going to say print, open parenthesis, and for strings, or basically say lines of texts, you have to use double quotes and nest them in between. I'm going to say my name is Divya. Here my name is Divya, so you can feel free to put in your name, feel free to put in anything you'd like, and just say run. Purpose of this, whatever is written here, it doesn't matter. It will just display. You could write A to Z. You could say Python sucks. You could say Python rocks. You could say I love programming. The compiler doesn't care what you write in there. It will just be directly displayed onto the console. So far, so good. Does anyone have any issues using the online GDB so far? Awesome. Okay. So let's do something a little more advanced. Now take off this code again. We're going to create a variable called my name. It's general, general methodology amongst programmers to capitalize the first alphabet of the second word, just to not have it too confusing. So you could do this. There's nothing wrong in that. You could just have name. You could have any variable name. I am just going to choose to have my name. And then I say equal to Divya. So like I said, once again, any word that goes past more than one character has to be nested within these double parentheses. Okay, so I say my name is Divya, and then in my output, I'm going to say print my name is, then I put a space. So your print function within it allows you to concatenate two different strings or a word and a number. So here I'm just going to say plus my name. So that is my variable name, as you remember. Okay. And then I say run. So when you say run, basically the program, then your computer basically looks at your program and follows the instructions. So here I say my name is Divya. So far, so good. Any questions, anyone? Awesome. Print. Next line, okay? Adding on to this code. What is your name? Okay, so you're asking someone, what is your name? So when you say this, it's just an output. But now you have to allow the person to give in and type their answer, right? So what you say is, you create a new name. You create a new variable, says your name, and then you say that's equal to whatever the person enters. So this input function basically returns, okay? This returns whatever the user types into the console. And that returned value is stored in something called your name. Just to you that, your name actually has whatever the user types back. I'm going to say print hi. And then your name. It's nice to meet you. So when you run this code, it will say, my name is Divya, what is your name? So here I'm just going to type, let's say this. Okay, so your name now stores whatever I typed. And the next line, it prints, hey, whatever I typed, it's nice to meet you. Everyone, so far, so good? Any issues, guys? Are you trying to do this? I would really like it if you try to do it. For sure, Kara. Is there anything I can help you with? Where are you stuck? Perfect, awesome. Anyone else, any issues? Please feel free to come up and ask me. You don't have to text. You can always just, unmute yourself and talk. Some interaction is always great. Awesome. Okay. So I guess we can move on. So this is a simple program. Okay. I'm just trying to show you the basic functionalities of what you could do with Python. Great. Awesome. So moving on. Python has many amazing and awesome features. You could do a lot with Python when you actually learn, and you could control a lot of things. Many strong programs that are written, many web pages, they're all done using Python. I'm going to show you basically some fun parts about robotics. Unfortunately, I'm not able to show you exactly how to do it in Python because of some software needs and some application needs. But we're going to use this online editor that allows you to just, use visual programming to do a simple Arduino program. I'm going to share my screen again. Actually, give me one moment. Awesome. So right now we are going to use this thing called Tinkercad. I'm going to share my screen again. Okay. So go back to Chrome, open a new tab, and type in Tinkercad. Let me actually pull up the PowerPoint for this because you will have to make a new account. So go to tinkercad.com and there should be an option on the top right that says join now. The link to Tinkercad has been sent on the chat box for anyone who's not able to find it. And then you have the option to create a personal account. So say create a personal account. And you should be able to sign in using either Facebook or Google, or you could just make a new account. I'm going to give you 5 minutes to get that done, and then we can get up and running again. Meanwhile, if anyone has any questions, please feel free to just, come up and ask me. Okay, has everyone created the account? A thumbs up or a yes would be great. We have 11 people here today. Awesome, perfect. So open up Tinkercad. So this should be your workspace, whatever you can see here. There should be an option on the left that says circuits, right where my mouse is hovering. And then go to create new circuit. Give me a quick minute, guys. I think my internet connection is lagging. So can everyone see what I am seeing here? Can everyone see the same as my screen? Awesome. So here on the right side in the search box, type Arduino. Okay. So what's an Arduino? Arduino is just a circuit board. So you have to click on it and then just drag it here or click back on your workspace, and it should come up for you here big and nice. It's basically just an electronic circuit board with, you know,
Hey everyone, we're just going to check and see. We're just having a couple technical issues here, so just hang tight for a second.
Hey, extremely sorry, I got cut off. Okay, I guess we'll just jump right back into our presentation again. So I'm going to share screen.
Sorry about that, Divya. I'm not sure what happened. I lost the Zoom link as well. So hopefully everyone that was in is able to still hop on.
Hopefully, yeah. So do you just want me to wait for a couple of seconds and everyone's back here? Because we're at 10, not 11.
You can go ahead. If I see them hop in, I'll admit them into the meeting.
Awesome. Okay. So everyone, is everyone good till here? Did you get the Arduino board into your workspace? Okay, I'm hoping yes. Awesome. So after that, we're going to make an LED blink like I was saying. So look for, go to the search box again here and type in LED. Grab the LED and drop it here. You will also need a resistor. So basically, like I mentioned, computer systems is basically a huge mess of electronics, right? So the amount of current that comes from the Arduino board might be too much. It might fry our LED. And so we're going to have a resistor. It's just something that, you know, helps you moderate the current and just make sure that the LED doesn't get burned. So be careful about the positive and the negative terminals. This is the positive terminal or the anode, and that is the negative terminal, much like how a battery has a positive and negative. When you place the component onto your workspace, make sure that you have the positive facing the resistor and the negative the other side. Click on this thing that says GND. GND means ground, or basically the negative, you know, the negative terminal. Connect this to the straight leg. Connect port 13 to the resistor, and then the resistor to the positive leg. So now the flow of current, the Arduino board gets current from our USB connector here, okay? From here, the current goes from port 13 to the resistor, to the LED, and then back to the ground, and again, and again. So that is how our current goes, and that's how the current is moderated. So if you say start simulation now, actually no, go to code, hit this thing that says code and say blocks. You probably already have these 4 blocks set in here for you. Okay. So it says set built-in LED to high, set, and then wait 1 second, set built-in LED to low, wait 1 more second. So you can change this. I'm going to say 5 seconds, and then I'm going to say wait only 1 second. All right. So if I say start simulation now, it will stay on for 5, and then it will stay off for 1. It'll go back again on, stay on for 5, and then off for 1. So I can change this by saying stop simulation. I could change this by saying be low and then high. And once again, start simulation. So it will stay low for 5 seconds, blink 1 time, suddenly get on, and then go back to off. So there are many projects that you could do with an Arduino, and that you could actually, code and not have these visual blocks. If I choose this option, blocks plus text, it shows you some code. This code, unfortunately, is not in the language that you learned today. This is not Python. This is a different language called C++. So don't worry too much about whatever is there. But even then, I think it is pretty, understandable the way the code is written. If you search here itself, Arduino, you can find many different configurations of, say, LED fade or a button press or a blink. You could even, program your Arduino board for the light to come on when you press a button, or say an LCD display monitor as displayed as shown here. So this could just display whatever message you'd like. So you could, in this LED monitor, you could have the option of saying, hi, my name is Divya, or hello world, or things like that. So Arduino really has a lot of applications. In fact, when I first started learning Arduino, I've tinkered around. I built like a simple security monitor system with just like a touch keypad. And this online simulator really allows you to do a lot with it. So it's great. Even if you just want to buy the kit, it isn't too expensive, I believe, and you can easily just plug it into your computer and just, tinker around with it a little bit. Unfortunately, I'm not able to help you guys program in Python itself, not just because of the IDE, the software, but also because of the complexity of the code. Let me show you. Actually, let's hop back onto Tinkercad for a minute. Did everyone understand Tinkercad? Awesome. So Colby says that he also did the same thing, a security system, when he started with Arduino. So I believe playing with Arduino is like a very basic stepping stone for most of the people who go into, computers and computer science, computer engineering, and just IT in general. It gets really interesting, especially when you have a physical board, you're plugging in all these wires, then you plug it in your computer and you're like, hey, I'm going to code this, please work. It's a lot of fun, a lot of effort, but it's a lot of fun. And the feeling when you finish writing a code and, have your system running, it's awesome. Like nothing beats it, really. So I just want to stop for a second and make sure everyone got this, they got their program to run. You guys can feel free to come up on the mic, like turn on the mic, turn on your camera and talk to me if you guys would like. Cool. Okay, so let's jump back to the presentation. Here I have a code for you. Okay, this is the code that you would use for a Python. So it's not the same thing. This isn't the key thing. This is a push button, like I mentioned. So here, to communicate to the Arduino using Python, you need to have it serially input. So serial input is basically one after the other, it's input and not all at the same time. So say you have a message, my name is Divya. Serial input means first M and then Y and then a blank character and then N, A, M, E, so on till A is input one after the other and not all at the same time. So this entire code is serially input into our Arduino board and then execute it. So what this does is this var raw input is basically input from user. When the person says 1, my LED is turned on, and I also have a message that says, hey, my LED is turned on. Yes, are you not able to see the code, Kara? Can everyone see my code, my screen? I am sharing my screen. Oh, my bad. Let's try this again. Okay, can everyone see it now? Perfect. Sorry for the mishap, and thank you for bringing it up to me. So this is the code, as I said, in Python. So here when I say if var is equal to 1, the var is the input that the person gives me. So where I said, what is your name? And the person entered their name in the online GDP compiler. It's something similar here where the person enters a 1 or a 0. And if the person enters a 1, my LED is turned on. So the common thing is that 1 is always a high or an on. 0 is always a low or an off. So here when I say Arduino.write 1, I am basically sending a high current to my LED, and I print a message that says LED turned on, and then I sleep for 1 millisecond. And then here, if the person enters 0, then my LED is turned off. And I also have a message in my LCD display which says LED turned off. So this is a simple Python program. It has some details that are, a little more complex. Example is Arduino serial.serial, which is a serial input, as I said, and these two import lines. So let me just quickly explain what those are. These are header files. So there are so many header files compiled and already written in Python for you. Just import and use. So all the pre-mentioned functions that I already said, like say print or Arduino files that allow you to use functions like Arduino.write, because Arduino.write is not a Python function. It's an Arduino function written by given to you by the Arduino company, the Arduino board. And to use these functions and not have the compiler throw errors at you, you need to import these certain header files, which have the definitions for these saved. Does that make sense to everyone? Okay, I guess silence is a yes here. So that is all I have about Python and all I have to share with you, with everyone today. If anyone has any questions, now I guess would be the time.
And Divya, to speak on Arduino. So this is what it looks like in real life. Now this is a mock board here, but this is pretty much what an Arduino is. This small little board can do everything from robotics projects, so underwater robots. It can do big robots. It can do really anything you want it to do. And it's a really powerful board. And there's a lot of great things you can do with it and with programming in general. And that's why we like to teach it to people, because programming, it's the future. And a lot of people are getting into it. And it's just a very humbling feeling to be able to make something. It's like art. And it's a really great feeling.
Just to jump in and add on to whatever Colby said, it used to be true once upon a time that, just people who are into the IT field or the computer field need to know programming. But with times evolving and, computers being so common around you, every profession, it's always a merit to know programming, at least base level programming like Python. Easy to understand, a powerful tool that can be used in many, many places. It's very, very helpful to learn and know how to program, basically.
That's amazing. Thank you so much, Divya, for that workshop, and Colby for showing us what it actually looks like. in person. That's really cool. This workshop was amazing. I'm a little bit like lost for words. I've never really learned something so intricate like that before, and your facilitation skills, given this is virtual, was really well done. So thank you so much for that. Your passion for robotics definitely shows in your facilitation skills. I got to say, Divya, that was amazing. And I really appreciated the examples that you gave. You know, you went through all of the different terminology and language used in the Python programming, and I feel like this workshop was done in a very user-friendly way. So I really appreciated it, being new to the robotics industry. And if anyone else is in the same boat as me, I hope it was the same. We have a comment there saying, thanks for making it so easy to understand. So that's amazing. I'm glad that was received around the table. And same with Divya, I would now like to open the floor to any questions the audience may have, whether that's for Divya or Colby. If you'd like to unmute yourself, feel free to go ahead and ask, or you can enter it in the Zoom chat and they'll be happy to help. And while you're thinking of any questions for them, I am inserting a Google form in the chat box now. It's a link. You just click the link and it automatically directs you to fill out a form. It's an evaluation feedback form. So we distribute these at all of our events, and it really just gathers your experience of today's event. So what you enjoyed about it, what you enjoyed about it most, what would you like to see in future events, and so on. We do really appreciate this feedback, and we value and consider it in developing future content. And for those of you that take the time to fill it out, you'll be entered for a chance to win an SCNL swag bag that we will mail to you. So I will just give it a couple of minutes there and see if anyone has questions before we clue up. So Divya, we have a question. Were you always interested in Python and coding? You seem so passionate.
So I was introduced to coding back in high school when I was in 10th grade. I did not know anything about computers. Like, I didn't even know what the command prompt is. Seeing as I'm in 3rd grade computer engineering student now, it's probably laughable at this point, but I didn't even know what a command prompt is. And with computer science, one of the subjects I took in high school, and I was introduced to C++ originally. And that being the first thing I learned, I saw how many things you could do with it. It was really cool. I stuck with it, but I didn't learn any other programming languages per se properly until I came to university. I was doing multiple hackathons, and my friends who were in my teams, whatever code I did in, like, say, 100 lines in C++, they did that in like 30 lines or 25 lines in Python. And that just motivated me to learn Python. So to date, I understand Python's easy to learn and easier to code, but C++ is like my favorite. It's like my baby for me, because that's what I learned first. It's where, you know, I discovered my passion for coding in computers. So I was always as passionate in coding. Python, I would say I recognize for what it is, but I would always, C++ is it for me.
That's awesome. Thank you so much for sharing that, Divya. I have a question, if that's all right for me to ask one.
For sure.
What skill sets would you say are really important to have in the robotics industry?
It is great to know some basic understanding of electronics and networks, the general working of circuits and electricity, and just, you know, basic electronic knowledge is always appreciated. Apart from that, I would say a basic understanding of coding, because I'm not sure what level of robotics even Colby is aware of, but I am sure that when all of us started, more than anything, it was a self-taught thing. When you understand the basics of electronics and programming, it's easy to just, you know, go out there and learn. So I would say you need to have a willingness to go out there, put yourself out and learn. Go to all these forums that say Tinkercad provides you, and all the forums that Arduino provides you, and there's so many controllers, and go out there, ask them, take their code, and, you know, understand it, and just be ready to learn, basically. That's all it is. Go out there and learn.
That's awesome. Perfect. Thank you so much for sharing that. And we have the last question of this evening's event. Is artificial intelligence and robotics the same form?
No, they're not. They could be interlinked if possible, but they're not the same, not necessarily. Robotics is basically just using your programming languages and electronics to make hardware do the things you want it to do. So say solve a maze using a certain program. But artificial intelligence, more so just machine learning, it basically learns from all the examples we feed it, understands the patterns, understands the behaviors, and then does things according to all the understood data. So machine learning doesn't have to be in the form of robotics. It can be used in robotics, but it is not necessarily the same.
Awesome. Thank you so much for answering all the questions, Divya. I greatly appreciate it. So that does conclude our virtual workshop. I just want to thank Divya and Colby one last time with the Canadian Robotics League for participating in today's event. And thank you to the audience for taking the time today to tune in. I hope that after the workshop, you feel more excited and prepared to dive into the Python programming like Divya and incorporate your work within the robotics industry. I'd also like to thank the provincial government for their support. Without it, events like this wouldn't be possible. So stay safe, everybody, and feel free to reach out to SCNL or CRL if you are interested in any future programming, or if you have any questions after what you learned today, please feel free to reach out and we'll be happy to help. I wish you all the best.
Thank you so much. Thank you, CRL. Thank you, Jess, for letting me come here and do all this today.
Absolutely.
You're very welcome.
Take care, everybody.
Have a great evening.